And then we got extra space here. Okay, so we can now go forward. All right, so this is the first question. First question is asking, we have a function that maps from D, which is our domain, to E, which is our codomain. And I want you to look at the function as a set, okay, which is what we have been focusing in this class is we look at functions as a function as a set. So the first part is, what is the largest possible cardinality of F based on, D and E, because, I also added this part here. Express both answers in terms of cardinalities of D and or E. You can also use arithmetic and set operators in the answer if that is necessary. So you can use addition, max, min, multiplication, and all kinds of crazy stuff like that. Okay, so what do you think is the answer to this one? What is the largest possible cardinality of F? Yep. No. The cardinality of D is the correct answer. Okay? Because the cardinality of the function has to be the same as the cardinality of the domain. Why is that the case? Okay, this is the answer. The answer is just bar D bar, but why?
Because D, every aspect of D needs to be mapped.
Every element of D has to be mapped. And as a result, there's a corresponding two tuple in F to represent that particular mapping. It's gonna get me at some point. There's a mosquito in here. Yeah. And I forgot to bring my bucket of salt. But if I did bring my bucket of salt, people in the front row probably have to put on safety glasses just in case those grains of salt land in your way. So that might sting a little bit. Well, this is rough salt on one session, so I guess it won't hurt too much. Okay, so it is D, and this answer is going to be bar D bar as well because it has to be exactly the same. Okay, are there any questions about this one? Well, it's only 2 points, okay, so if you mess with this one, it's not too bad. Okay, but are there any questions? I mean, do you guys have any questions about this one? Why that is the case? I mean, you have to understand why that is the case. Because in order for a function to be a function, each element in the domain has to be mapped exactly once to the codomain. Now, how big is your codomain? It doesn't even matter in this question. Your codomain can be infinitely big when your domain only has 2 elements. It doesn't matter because whether it's surjective or not doesn't have anything to do with this. Whether your function is injective or not also has nothing to do with this. It just has to be mapped. Everything has to be mapped exactly once. Can they all map to the same thing in the codomain? Sure, I don't see why not. Okay, can they all map to all unique elements in the codomain? Yeah, that's fine too. But they have to map once and only once. Exactly once. Okay? So that's why bar D bar is the answer to both of those questions. So the rest is really to throw you off. You can use max, min, any set operators, and so on and so forth. That's just completely to throw you off. Okay. So is that okay so far? Okay. So moving on to question number 2. Question number 2 is basically saying that, so this time I spell out what is the domain and what is the codomain. The domain is what would be the numbers 1, 2, 3, and then the codomain would be the letters A, B, and C. And function G has exactly the same domain and the same codomain. So I want you to come up with an example. Okay, there are many ways to do this. Okay, so you just have to pick one single example to define F and define G, so that their intersection is an empty set. They do not share anything. So if you think this is impossible, also explain why that is impossible. Okay, so I leave an option here for someone to say it is impossible. So first of all, is it possible?
Yes.
Okay, and there are many ways to make it possible. Okay, so one way to make it possible, one case is you're defining f so that everything maps to, say, A, okay? So we have 1A, 2A, and then 3A. It is f a function when it has this mapping, okay? And then G can be a set of 1B, 2B, 3B. Then these two sets have no intersections anymore, or I should say the intersection is an empty set. Because the element 1A, which is a 2-tuple, is different from the element 1B, which is also a 2-tuple. Is that part okay? All right. Okay, so that's another 2 points. Question number 3 is mechanical. Yep, go ahead.
Did you do f equals f minus f?
Sorry?
Did you do f equals f minus f?
F equals f minus f?
Yeah, f equals.
Okay, there's only one time when f equals f minus f, when you're using the subtraction operator in set operations. When is that the case? When do you think the set f has the same elements of the elements of f, but not in f? When f is an empty set. So this equality can only be true when f is an empty set. But when f is an empty set, is it still a function when we have the domain of 1, 2, and 3? That's right. So it cannot be, that cannot be an answer. Okay, there we go. So question number 3 is kind of mechanical, and I think I made this one pretty easy. Okay, so let's go ahead and figure out why I say that it is pretty easy. Well, okay. The pretty easy part is for the resolution part. Okay, so you still have to make sure that you get to the correct CNF first. But once you get to the correct CNF, then you combine it with the correct approach, which means you have to negate the theorem first. So you still have to get all of those steps right. But once you get all those steps right, the actual resolution is like, oh, really? Okay, so let's go ahead and work on this one. So the first one is we got P plus R, because I'm using the easier notation here, implies Q. Okay, so we want to say, okay, what this is really saying is the same thing as the negation of P plus R or Q, right? And then you apply De Morgan's law. De Morgan's law is going to distribute the negation, this one here, into the interior, and also change the disjunction into a conjunction. So now we have not P, not R, plus Q. And this is still, is this in CNF?
No.
Yeah, yep, it is in CNF. Oh, it's not, sorry. Okay, I take it back. It is not in CNF yet, because the conjunction has to be last operation. It's not in CNF yet. So what do we do to convert this one into a CNF? Distribution, exactly. So using distribution, so now we have here not P or Q and not R or Q. There we go. All right, cool. Okay, the next one is kind of easy. Q and not S. Is that the CNF already? Is it only consisting of conjunctions? Yep, so we're done. Now you might want to just rewrite this one using some extra parentheses just for clarity, because the extra parentheses will help us identify what can be used in the resolution step. Are there any questions about these two? Now I still have one more thing to do, because the question is asking derive the CNF singular. So I have to combine these two. So I have to say the CNF is copy and paste. Okay, paste. Like that. Okay, so we're done with this particular question, because I do want you to combine everything into one single CNF, just like with the homework assignment. Okay, so now that this is the CNF, the next part of the question says, then use resolution and proof by contradiction to conclude whether the following is a theorem or not. So I present the theorem is S implies R. Okay, that's the proposed theorem. Show all steps of a proof by contradiction. Please indicate which two clauses resolve to which result in each step, and clearly state the conclusion. In other words, just don't stop the resolution steps and go, okay, I think Tech knows what I mean. Okay, look at the end result of the resolution and tell me, okay, how you interpret that result of the resolution. Okay, so I'm going to do this part here. So you have to start with the negated theorem is the negation of S implies R. Okay, that's pretty easy. But you do have to say that. Okay, now it may not be using exactly the same words. If you want to say negated theorem, colon, blah, 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 that's fine too. But you have to tell me that you know that it is important to negate the theorem that you're trying to prove first. Okay, so it has to be there somewhere. Okay, so now you have to convert it into a CNF. So now we just say, okay, this is the negation of not S or R. And so now you use De Morgan's law. So now we have not S and not R. And then you remove the double negation, so it becomes S not R. And obviously, it might be helpful to add some extra parentheses as well, just so that it's easy to identify the boundary of each component. Okay, so now the CNF combine the negated theorem into the CNF. So now we have a longer CNF, only longer by a little bit, by this much. And now it's time to do the resolution. Okay, there we go. And it is, okay, let me scroll up a little bit just so that you guys can see how obvious it is what we need to do to resolve it, right? Because the S and the not S are right next to each other already. So you basically just, you can use any approach you want, okay? You can either just boldface both of these. Well, you cannot boldface when you're writing, you can just use underline, single underline, double underline, or whatever, okay? Just indicate that these two resolve to a 0, okay? And I'm going to use italic here to indicate this is the result of the resolution, okay? So now you have to tell me what this means, okay? So you have to say the CNF resolves to false or 0, okay? Yeah, because they mean the same thing to me. And since we conclude with a contradiction, the theorem is true. Okay? Yep.
Technically, we didn't resolve it, right?
Sorry?
Technically, the contradiction was already there.
The contradiction is already there, but we need the resolution to actually see that there's a false. In other words, with every single proof where you use proof by contradiction, the contradiction exists already. You're just discovering the path to find that false. So, but that's the most important part. The most important part is to actually find the path so that you can conclude and say that, oh, okay, we arrived to a conclusion of false.
Okay.
Yep. And also, I'm just testing this whether people understand how resolution works. So are there any questions about this one? No questions? Okay. Moving on to the next one. There we go. Okay, so the next one is we have a function. Okay, so the next one we have a function f that is defined later on, and then z plus is basically the set of all the positive integers starting with 1, and the function is x mod y. I was kind of surprised, pleasantly surprised, that nobody walked up to me and asked, what is the mod operator? Okay, so that was good. Okay, it was good. So x mod y is function f, but the relation, x r y if and only if x mod y equals to 0. What does it mean when x mod y equals to 0? When x and y are both positive integers. It's a factor of. Okay, so basically y is a factor of what x is r. Okay, or since we're using x or y, r is a multiple of. Okay, x is a multiple of y. Is that okay? All right. So the first thing we want to ask ourselves is it reflexive? Is a number its own factor or its own multiple? Yep. Okay. Is it symmetric? If x is a multiple of y, then y is automatically a multiple of x. Nope, doesn't make sense, right? Is it transitive? If x is a multiple of y and y is a multiple of z, is x a multiple of z?
Yes.
Yes. Okay, very good. And then the last one is equivalent. Well, since it is not symmetric, it cannot be equivalent. So you can automatically answer false here without even knowing what the function is. So are there any questions about number 4? Yep.
You said multiple?
A multiple of. So basically R is a multiple of.
How are we figuring out the mod? I guess I'm kind of confused.
Because mod is returning the remainder of a division. So if the remainder of x divided by y is 0, that means x is a multiple of y. So 12 mod 6 is 0. 12 mod 3 is a 0. 12 mod 5 is 2. Because it's the remainder of the first number divided by the second number. Okay. All right. All right, question number 5. Question number 5 also has a whole lot of degrees of freedom. Yeah, question.
For the last one, we didn't have to like define the function. Right?
You don't have
We didn't
to.
have to like write the condition where it had to be like x mod y and
You don't have to quote the definitions of those terms.
We didn't. Do we have to write define the function above?
No, because it's already defined for you.
okay.
The function is already given to you as x mod y.
Because that it was the furthermore part of the question was.
Hmm?
That's right. Extra work is fine.
Can you give like a example of what example domain and codomain would be of that? Because
The domain is z plus. Well, in this case, I just chose to use z plus as my domain, which is 1, 2, 3, 4, and so on. And then the codomain is exactly the same.
so would it be like 1 maps to 1, 2 maps to 2, or something similar?
Oh, because it should be a cross, right? It should be x mod y,
Yeah.
x z plus comma cross z plus to z star because because we have to include 0. Okay. Yep, I did mess up in that one. Did you guys understand what he just said? Okay. The correct way to ask the question is we have to, instead of doing that, it is that, and since the result can contain 0, so we have to do a right arrow of z superscript star, which includes 0 itself. So this would be the correct way. What I did earlier was incorrect. But since I did define the function itself, as f of xy is x mod y, so that would still, it still gives you enough to work on the problem. Did anyone get caught up with because of the inconsistency? How many people noticed the inconsistency? That's one. Okay. All right. So number 5, question number 5 has domain being defined as D is 0, 1, 2, 3. I want you to find a subset of D cross D, the Cartesian product of D and D, so that when seen as a function, S is bijective. When seen as a binary relation, X is not reflexive, not symmetric, and I forgot a not here, but in class, I did write it on the whiteboard that there's a not in front of the transitive. And express S as a set. If this is not possible, explain why that is the case. Okay, so right off the bat, how many elements are we expecting in S? 4 because it is a function. Okay, whether it's bijective or not doesn't even matter. Okay, we know it has to have exactly 4 elements. Okay, very good. So when we're constructing S, we can basically say, okay, there are exactly 4 elements, and each one is a 2 tuple. And we already know that the first item has to start with 0, 1, 2, and 3. Okay. So the only thing you have to do is to figure out, okay, what do I use as the second number of each 2 tuple? Okay? So what do you think? You have to make sure it's not reflexive. So 0, 0, 1, 1, 2, 2, 3, 3 does not work because that's reflexive. What about 0, 1, 1, 1, 2, 1, 3, 1? That won't work either because it's not bijective. We want it to be bijective. How do you make it bijective?
Every injective and surjective.
Yep, so everything in the range has to be mapped. But since we have the same number of elements in the codomain as there are in the domain, surjectiveness actually ensures injectiveness in this case. Does that make sense? When the cardinality of the domain and the codomain are exactly the same, surjectiveness actually guarantees injectiveness, and vice versa. Okay, so that makes it easier. So we just have to make sure that they each pick a different second element. So 0, 3, 1, 2, 2, oh, I don't know, 2, 0, and then 3, 1. Okay, that works. Is that okay? Yep. Sorry? What if what?
What if you pick 2, 1?
What if I?
Instead of 2, 0, you pick
Yeah,
2.
okay, so if you have 2, 1, you have to change the 3 to a 0, right?
Would that work?
That will work as well.
1, 0, 2, 1.
Oh, it becomes symmetric, so it won't work. If you change one pair to be symmetric, the other pair is automatically symmetric. So that won't work. On the other hand, you can do something like that though. Oh, that won't work. You can make one of them, reflexive. No, but that's not reflexive.
Can you just do a 0, 1, 1, 2, 2, 3, and 3, 1?
Okay, hold on. 1, 0.
1.
1, 2.
Yeah, 1, 2, 2, 3. And then 3, 1.
3, whatever is. Well, 3 has to go back to 0. 3, 1 won't work.
Oh,
Because
I meant 3, 0.
Okay, 3, 0 will. Okay, so let me just explain to the class why 3, 1, the one that we have right now, does not work. This one doesn't work because it's not bijective anymore. Because we have 0 and 3 both mapping to a 1, so it's no longer bijective. But on the other hand, if I change this to a 0, then it works because it is once again bijective, but it also satisfies all of the other requirements of being as a relation. It is not reflexive, not symmetric, and not transitive. Now, you can also do something kind of weird like this and just have this one mapped back to 0. It is still meeting all the requirements because just having 3, 3 doesn't make it reflexive. Reflexive says for every element, you have to be able to relate to yourself. 0 doesn't relate to itself, 1 doesn't relate to itself, 2 doesn't relate to itself. Okay, so that means as a relation, it is not reflexive. So even this answer is correct. But the moment you make 2 elements reflexive or relating to itself, then it's guaranteed not to work because whatever is left is guaranteed to be symmetric. So there are kind of little things that you will pick up, as we try to work out the examples. But this is one of the easiest, answers. It's just to keep going forward and then wrap it around. So are there any questions about number 5 before we get to the last one? No questions about number 5? Okay, so for the last one, I goofed. Okay, I actually, this question is wrong, but not in the same kind of trivial way as the other one. This one is kind of wrong because instead of using if and only if, I should have said something else. Because it goes in one direction, but not in the other direction. If G and F are both injective, then the composite is guaranteed to be bijective. That one is for sure, okay? And it makes sense too. But the other way around doesn't work. If H is bijective, it does not guarantee that the composing or the elemental or the individual, the component functions are also bijective. That part is not guaranteed. I can give you a counter example to show that direction does not work. Okay, so I'm going to use, I'll use the whiteboard, I'll use the projector as an example, okay? Which basically means, that side of the equation, I cannot give you, I cannot take any points, okay? No matter what you say, I cannot take any points. If you don't say anything, I cannot take any points. Okay, so I'll give you an example, okay? So we have F here, we have G, okay. So we want to define G to be a particular function, and we can make it as simple as possible. Yep, go ahead. Oh, sorry about that. I need 2 pieces of Scotch tapes on my monitor. One to mark this line here, and one to mark that line over there. And in fact, we do have Scotch tapes. So I can put one here, and I put one down there. And just to make sure they're visible, I can use a marker to actually write on it. So this way they stand out. There we go. So who else teaches in this classroom? I'm hoping Mr. Fox or Subsidiary will teach in this classroom, because I like to see their reaction to who put that Scotch tape on the monitor. And what for? Do not go above this line, do not go below that line. Why not? Okay, so I'll give you one really quick example here. Let's see, G is map. So, okay, G is the last map, so we have to start with F first. So we'll start with F, and let's see, we'll make F maps from 1 to 1. There we go. Okay. And this is obviously a set. Okay. But the other thing is we have to define what is the domain and what is the codomain, because if I define the codomain to only have the element of 1, this is surjective, because the only thing in the codomain is used. So I have to give you exactly what is the domain. The domain is just the set of 1. The codomain in this case, I can say it just has to include 1, right? But I can also have 2, 3, 4, and so on. Okay, would that make F a function? It has one single element in the domain, being 1. It has multiple elements in the codomain, 1, 2, 3, 4. And the only mapping that I have is from 1 to 1. Is that a function? Yep, it is a function. Very good. So now I can define G. But once again, I have to define what G is, in terms of the domain. I don't have a choice here. The codomain of F has to be the domain of G, because that constraint is in the question itself. Okay, so G is that, and then G can map it to. Can I have something like that? Sure, we can, because now we can define G as a set to be 1 maps to 1, 2 maps to 1, 3 maps to 1, and 4 maps to 1. Is that okay? Why not?
Does F and G have to be bijective?
Sorry?
Didn't it say that F and G had to be bijective in the question?
Yes.
But F isn't bijective.
F is not bijective, G is not bijective either in this case. So the question is the composite bijective?
Yes.
The composite is bijective, okay? The composite is bijective because when you look at what is f of 1 is 1. What is g of 1? It is also 1. So when you look at the composite, which is the g of f of something, what is it? Yep,
But
go ahead.
It doesn't have to map to something unique for it to be injective.
In order for the composite to be injective, yes.
Okay.
So I'm trying to prove that my question itself has a problem, because my question suggests that if H itself is bijective, then the component functions are also bijective. But that is actually not the case.
Oh, okay. You didn't get H of X
Say
here.
if the components were bijective, that the result has to be bijective.
Say that one more time.
When I read the question, I thought you were saying, like, if the components are bijective, then the result will get it.
That's one part of it. Okay, but yeah, go ahead.
So if you were to set up the proof, assuming you wrote it the right way, so assuming you wrote the question correctly, would you like say f is not bijective, say one of the two functions is not bijective? Could you somehow say in terms of cardinality, there is no way that the composite function will be bijective if one of the functions?
Not quite.
Because this, yeah.
But when we look at this, okay, when we define h of x to be g of f of the original number, is that bijective? It is bijective. Because
this basically,
because the domain of h has only one element, but the codomain of h also only has one element. When your domain and codomain only have one single element, that function has to be bijective. There's no other way to do it.
So I was just thinking of greater than, less than. Yeah, you have to check if there's one element that's also a condition.
Okay.
You know what I mean? Like if you don't check for if it just has one element, but
Mhm.
you just say that if it's greater than or less than, like if f had a cardinality where the domain is greater than codomain, and g was say bijective,
Mm-hmm.
because we find
If at least one of them is bijective, the other one has to be bijective as well. But in this case, f is not bijective, and g is not bijective either.
It can be bijective or it can't, depending on how you set it up.
It can be, correct. But what I'm trying to get to is one direction of what I'm asking you to prove is not true. Because in this case, tag is wrong because he shows a case where h is bijective. Are there any questions about whether h is bijective or not? H is clearly bijective because the domain has one element. The codomain of h also only has one single element. So it has to be bijective, okay? Does not imply the component functions g and f are bijective. Because in this case, f is clearly not bijective. If it's not bijective, why is it not bijective? Which requirement is it missing? It is not surjective, not surjective. H is also not bijective. Why? How is it not bijective?
Not injective.
It is not injective. Very good. Okay, so in this case, H itself is bijective, but the component functions g, f, and g are not bijective. So we have a problem because this direction does not work. Okay, so that means this part cannot be proven. You cannot prove that. Okay, and I did not ask you to to comment and say why you think this part cannot be proven. Give me a counter example. So if you don't give me an answer at all in this direction, it'll be fine. Okay, I'm not going to take any points off. But the other direction is still true. Yep, go ahead.
Oh, just itching my head.
Oh, okay, sorry. There we go. Okay. So the other direction is still true, but this question also asks you one more thing because I want you to use proof by contradiction. So without even dealing with function being bijective and whatnot, the first thing you need to do is to say, well, let's negate the theorem first, right? So when you negate the theorem, what do you get? What is if and only if? How do we, is there a symbol representing if and only if?
Double implication error.
The double implication, very good. Okay, so the double implication represents if and only if. So let's go ahead and see what that would mean. So let's just use A means the composite function is bijective. Okay. I'm just using a symbol here so that I don't have to repeat long sentences or long statements like that. And then B is the second part. G and F are both bijective. Okay, so we copy and paste it here. Okay, so the question is really saying the theorem is A if and only if B. Is that okay? So how do you negate that? Okay, so the negated theorem is what? Well, first of all, it is just the negation of that, right? But then what do you get? Okay, so let's go ahead and do this derivation because we should have enough information to do this. What is A is A if and only if B, which is also known as equivalent to. Can we break it down into smaller components? What is the definition of the double-sided arrow?
A implies B and B implies A.
Yep, very good. So we have A implies B and B implies A. Okay, so A implies B and B implies A. Okay, all right. So can we go even more elemental in this case? In other words, how do we represent implies? Is there a way to break it down into smaller components? A implies B is not A or B. Very good. Okay, so we have not A or B. So I'm shifting to the easier notation here. And B implies A is not B or A, right? Okay. Okay, so now we got this. What rule should I apply now? There are two potential rules that I can apply right now. I can apply De Morgan's law. Okay, I can make the outer negation distributed to the inner part, or I can apply distribution. So I would apply De Morgan's law first. Okay, it just seems easier to apply De Morgan's law first. Okay, so after De Morgan's law, I have the negation of not A or B. And then we have the or, because the conjunction becomes a disjunction, the negation of not B or A. Okay, now we have to do the De Morgan's law one more time, because we have to distribute this negation to the individual components here, and then change the disjunction to a conjunction, and do the same thing on the other side. So what we end up with is the negation of A and the negation of B, or, and then the other side is kind of symmetric, the negation of B and the negation of A. And then we look at double negation and go like, yeah, those guys can go away. So now we have just A and the negation of B, or B and the negation of A. That's the final answer. But what does that mean to us in this group? That means you have two subcases to deal with, in the actual proof. Because the first one, let me just highlight which one I'm talking about here. The first one, which is A and not B. Remember, A is just a placeholder for something that's a lot longer, right? So the highlighted part here is really saying the composite function H is bijective, but G and F are not both bijective. Does that make any sense? So you have to prove that that is false. And then the other one, which is this one here, is saying exactly the opposite. Okay, it is saying that B is true, which means G and F are both bijective, but A is not. Okay, A is not true, which means the composite function H is not bijective. So you have to show me that both of these cases are impossible in order to prove by contradiction. Is that okay? How many people got to this point? Just negating the theorem itself and breaking it down to the components and go like, okay, we have two cases to deal with. A few people? Okay, very good. Oh, question, okay.
What if I approach this one by using cardinality?
Using cardinality. How do you use cardinality in this case?
I said that usually that level bijective, so I have the cardinality of D,
Mm-hmm.
E, and E to F.
Yes.
And then I said that the theorem H is not bijective using the proof by contradiction.
Mm-hmm.
And I say that because B equal to E equal to F, so B has to equal
But you can find cases where the domain and the codomain have the same cardinality, and yet the function is not bijective. Because the mapping can go just like this, right? You do 1, 2, 1, 2. Okay. This is our domain. This is our codomain because we're going from D to F in this case, right? That is not. That's not bijective.
But
Yep.
to her point, for F to be bijective,
Yes.
that means everything in D has to map to something unique in E.
But then you're not only using the cardinality because that's her answer. She's basically saying that can we use only cardinality in this proof? And the answer is no. You cannot just use cardinality. Yep.
But if she used that H is not bijective if only if G and F are both bijective, isn't in what you're starting out with, the assumption that G and F are already bijective, so you don't need to prove it.
That is correct. You don't have to prove that G and F are bijective.
Then by just using the cardinality of them, you can prove H is bijective because you're already assuming that the other two are bijective, so you don't need to deal with what they're actually mapping. Now you don't need to deal with their cardinality.
But your proof has to go back to the bijectiveness. You have to mention that
You can't just like assume it because it's part of the assumption you're given.
But because it is a part of your proof, you have to clearly state which part of the assumption is the part that is leading to the contradiction. Yep, go ahead. Oh, I thought somebody had a question. Okay. Okay, so in one direction, it is actually possible because I have just illustrated it. Because I have just illustrated that G and F, none of them is actually bijective, and I still end up with H being bijective, which means A not B is actually possible. Okay, so there's no way you can actually prove the contradiction to this one, but we can do this one. Okay, this one is still true. So how do we prove that? So we want to prove B not A. B not A is basically saying G and F are bijective, but H is not. Okay. So how do we prove that? See, that line is really useful. I remember when to scroll up now. Okay, so how do we do this? How do we show that we have the component functions being bijective, but the composite is not bijective? What is that really saying? Okay. How can H be not bijective? It can be bijective in two different ways. It can be not bijective because it is not injective. It can also be not bijective because it is not surjective. Okay? So in the case of maybe H is not injective. Okay? But if H is not injective, what does it mean? There exists at least one element such that da 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 da. What does that mean? If H is not injective, what does it mean? It means it does not map the domain elements in the domain to unique elements in the codomain, right? But since we know that now you can use the cardinality. Okay, so you can combine the two and say that since we know the cardinality of all three sets have to be exactly the same, now that you are assuming that H is not injective, that means one thing in the codomain of H is not mapped. Does that make sense? Okay. Okay. So so if I write down here, then I will say since the cardinality of E equals the cardinality of E, D and E and F, they all have the same cardinality. H not being injective means there's some element X in F, sorry, that is not mapped. Okay. And why would that be a problem? Well, we know G is bijective, right? Yep. No, it is in F. It's in the codomain. injectiveness has to do with unique elements, right? So if it is not unique, that means there are two things mapping to the same thing. So from the pigeonhole principle, you know that there's one element in F that is not getting mapped to. Is that working out for you or not? Okay. So if F is not, so it also means that H is not surjective either, okay? Because in this case, not injective also means it is not surjective. But why is this causing a problem? Yep.
Because it's implying that like G isn't injective. Because if there's something in F not being mapped, then there's something in E mapping to two of the same thing.
The two to the same thing can either happen in F or can happen in G, but one of them has to be non-bijective.
Yeah.
Okay, so that would be
Which is
the
a
argument,
contradiction.
which is a contradiction to the assumption. Exactly. So that's basically your answer. Okay. So you can basically, so at this point you can say, but this happens only if F or G is not injective. And the contradiction. Because you're given that G and H are both injective, and now we come to a conclusion that they cannot be injective because H is not injective. So we have a contradiction, proof is done. Now the other case of H not being surjective is the same proof, because H not being injective and H being not surjective are exactly the same thing in this case. And it has to do with D and F have exactly the same cardinality. So when you have a function where the domain and the codomain have exactly the same cardinality, then not having injectiveness also guarantees not having surjectiveness. Having injectiveness also guarantees surjectiveness. And no, you do not have to prove that also. So I will leave this one as the correct answer, like that. So you don't have to use exactly the same terms. Any way you can show me there's a contradiction due to the injectiveness or their lack of, I would count it as an answer. But you have to, but the steps has to be clear. Is that okay? All right. So that wasn't too bad. I would call this low sodium. No? But are there any questions? If you guys have any questions about the answer to any one of these, this is a good time to ask. Yes?
Go back up to the previous problem.
Go back up a little bit.
The previous problem.
To which one?
The previous problem.
To the previous problem. Question number 5.
So what would make that set transitive? Would you have to add like a...
Oh, to make it transitive? Oh, to make it transitive, you will have to add a 0, 2. You will have to add 0, 0. You will have to add 1, 0. So you have to add a bunch of elements, which by that time is no longer a function, because now you have multiple things from the domain mapping to the same thing in the codomain. No, I take it back. The same thing in the domain will be mapping to the multiple things in the codomain. So it cannot be transitive. Yep.
For 6, for the functions,
Yep.
could you, I wasn't sure about this, but could you say that D map to E is similar to D implies E?
But implication is a Boolean function.
But it's like, if you were to choose one value, then it would imply a certain value out of...
But any function does that. It's just whether it is a unique value or not, and whether you use up everything in the codomain or not.
So that can't be a condition?
You cannot draw a parallel between implication and a function.
Okay.
because they are different things. I can see how you can see that it's still kind of, the first thing has something to do with the second thing, right? But it's in a completely different way. All right. So are you guys ready for homework assignments? Yes? Okay. So here's your first, this is your homework assignment after a long while of not having any homework assignments. This one is in discrete probability, and I'm hoping it won't be too difficult. It's called experiment space generator. So before we talk about this, we'll first have to talk about what is an experiment, what is an outcome, what is an event, and that sort of thing, which is in this particular slide here. So we'll go to that slide and just talk about it first. A trial is a single attempt. A trial usually involves some kind of action, but always has a result. Okay? You throw a dice, that's a trial. You flip a coin, that's a trial. You draw a single ball out of the lotto cage, that is a trial. Is that okay? So it's one single action that can possibly have multiple outcomes, but it's one single action. That's the key. Is that okay? All right. So in probability theory, an outcome is a possible result of a trial. So when you throw a dice, like a regular 6-faced dice, then the values that can be outcomes will be 1, 2, 3, 4, 5, and 6. If you put 36 balls with numbers, unique numbers, 1 to 36, into a cage, and you randomly draw a ball out of the cage, then there will be 36 possible outcomes, right? 1, 2, 3, 4, all the way up to 36 are the possible outcomes. So are there any questions about the relationship between a trial and an outcome? A trial is the action, an outcome is a possibility of a trial as the result of a trial. Is that okay? Okay. So then we talk about an experiment, okay? So an experiment is essentially a sequence of trials. So a sequence of trials is an experiment. So when you draw the balls for lotto, it's an experiment because you're drawing 5 consecutive balls from the same cage, in that case without replacement, but it is still an experiment because it is a sequence of actions that results in the 5 balls that you have in, out of the cage. Are there any questions about these terms? So when you look at kind of graphically, a single trial is going to fill up one single space, and then the outcomes are basically, okay, what are the values that can go into this place? If you throw a dice, okay, if you throw a dice, then the values 1, 2, 3, 4, 5, 6 can go into this box here. On the other hand, if you throw a dice 3 times, it is now an experiment because it is a sequence of 3 trials. So now you have 3 slots to fill in, and since when you throw a dice, it cannot be without replacement, because after you throw a dice once, the dice does not become a 5-faced dice, right? So now the second one also has 1, 2, 3, 4, 5, 6 as potential outcomes, and then the last one also has 1, 2, 3, 4, 5, 6 as the potential outcome. Is that okay? So are there any questions about a trial, outcomes of a single trial, and the concept of an experiment, which is a sequence of trials? No questions? Okay, that's all we need to know. Okay, there's more stuff down here, but I'm not going to talk about it because it doesn't relate to the homework assignment just yet. So I will stop with this part and go back to the homework assignment, or the description of the homework assignment. So your homework assignment is called an experiment space generator, which essentially I just want you, okay, so this time I'm making it very flexible. You can use C++, you can use C, or you can use Java to accomplish the following. So use whatever programming language out of these 3 to get this accomplished. Okay, so I really don't think that people will want to use Perl or Python or PHP. Does anyone have any alternative programming languages that you want to use? No? Okay. Just checking. No Visual Basic. There's no way I can run Visual Basic on a Linux computer, not easily. Okay, so the first thing your program has to do is to read the configuration file. The file name of the configuration file is always spacegen.conf. Okay, so this one you can hard code into your program. The first line of this configuration file is an integer. The integer indicates the number of trials per experiment. Okay, is that okay? So in our example here, this would be 3. There are 3 trials in each experiment. Okay. The second line indicates the initial number of outcomes per trial. Okay. In our example, because we're throwing the dice, we have 6 possible outcomes in this case for the initial trial. Now I call initial because if it is without replacement, then the next trial only has 5 possible outcomes. The third line is an integer from 0 to 1, which indicates whether the outcome is with replacement. Okay, so if it is with replacement, it has a 0. If it is without replacement, it has a value of 1. Is that okay? In the case of throwing dice, it is without replacement. In the case of drawing balls from a lotto setup, then it is, no, this is with replacement. I take it back, sorry. When you're throwing the dice, it is with replacement, and then when you're drawing the ball out of the lotto cage, it is without replacement. Okay? The output of your program is going to be a file that contains all the possible outcomes or all the possible outcomes of individual experiments. So I should make it more clear. Let me add that. And I'll give you a sample too. So I'm not going to get out of the edit mode just yet because I'm going to give you a sample. So represents an outcome of an entire experiment. Okay, all right. So let me give you examples. Okay, configuration file says, okay, let me read my own documentation here. Number of trials, number of outcomes. Okay, all right. So let's say we have 3 trials per experiment, and then we have 3 possible values per trial, and it is with replacement. So I put a 0 here on the third line, and then the last one is going to be the name of the output file. So I'm going to call this outcome1.txt. So if this is the input, okay, so this is the following is the input of the configuration file, and the name of the configuration file is always spacegen.conf, spacegen.conf. Then the output of this program is going to be what? And everything is 0 oriented. So on the first line, 000, 001, 002, 010, 011, 012, and then you have 020, 021, 022, and then you have 100, and so on. How many rows do you think this file is going to have? The last one is going to be a 222. What is going to be the number of lines of this particular configuration? 27, okay? 27 because it is 3 to the power of 3. Is that okay? On the other hand, if I change the configuration file so it is without replacement, okay, so let's go ahead and take a look at the case. What happens when we take out that part so that, or change this part so it is now without replacement? And the output file is now, let's call it outcome2.txt. So in this case, the file is going to be a lot shorter because we have, if the first one is a 0, you cannot use 0 anymore for the second one. So I only got 2 choices. The second one can be either 1 or 2. But once I use 0 and 1 for the first 2 trials, because it is without replacement, the third one can only be a 2. Is that okay? Can be a 021, can be a 102, can be a 120, can also be a 201, can be a 210, and that's it. because this is how many ways I can arrange things when you are choosing 3 out of 3. Yep.
So does that mean without replacement is it factorial? So that would be 3 factorial? Or how does it
Not necessarily. It is related to factorial, but this is more precisely permutation. Because in this case, it's the permutation of having 3 items to choose from and choose exactly 3 items, which works out to be 3 factorial. But in general, it is n choose r, but you're dealing with a permutation. But because I'm separating the the number of trials per experiment from the initial number or the initial number of choices that you can choose from. So this means, I can tell you that we have 6 choices for the first trial, but you are only running 3 trials. So in that case, it will be the permutation of 6, 3, and not 6 factorial.
Okay, so just if you have 3 trials and you have 3 outcomes, that it comes out to be.
Correct. So in this case, if this is not throwing a dice, but instead it is a lotto type of setup, if the first one, the second one, I don't know which one is not available, but I know one of them is not available anymore. But for the third trial, I know 2 of these 6 numbers would not be available anymore because I have used up those 2 in the first 2 trials. Is that okay? So that's your homework assignment. But before then you guys are gonna go write your program. How would you write this program? You cannot use nested loops anymore. Okay, because that was the first idea, right? I can just use a nested loop. But since I didn't tell you ahead of time how many trials we are dealing with, you cannot use nested loops. Well, at least not in the most conventional way, because the most conventional way is kind of like this. Okay, let me go back to my text here. So the most conventional way is to say, okay, for let T be an array of all the trials. So you can say let T bracket 0 equals 0, T bracket 0 is less than n being the initial number of possible choices, plus T bracket 0. And then in the nested loop, you can just say, okay, we can do exactly the same thing with T bracket 1, and then we can do the same thing with T bracket 2. Right? If I told you ahead of time what is the number of trials, then you can probably do something like this, if you don't mind being tedious. But since I did not tell you ahead of time how many trials I want to have per experiment, you cannot make it static anymore. So what do? Yep. Recursion, exactly. So you have to use recursion. Is everybody familiar with recursion, or at least the concept of recursion? Okay, so with recursion, you can deal with it. But recursion is easy when it is with replacement. When it is without replacement, even the recursive algorithm still needs something, because you need to tell the next invocation what are the remaining choices. Okay? Because because once you have chosen one, so let's say this is without replacement. Okay, if it is without replacement, and you say, okay, the first one I'm choosing 2, that means 2 is no longer available from here on, right? So when you do the recursion, you have to say, okay, for the second invocation of the same function, we only have 1, 3, 4, 5, 6 as possible choices. So let's say out of these we choose a 4. Okay, this is just for example. So that means 2 and 4 are now both used up, and the third one, the third trial, can no longer use 2 or 4. It has 1, 3, 5, 6 to choose from, but not those 2 that have been chosen already. So you need to find a way to represent that and pass it as a parameter to the next invocation. So as a big clue, okay, whether you're using Java or not, well, not sure about Java. Can Java pass an array by value? Okay, who took cisp440? You can pass it by value. I don't know about that.
Yeah.
Sorry?
You can pass a whole array into a function.
No, I know you can pass, but you pass it by reference or you pass it by value?
You can't represent the
I don't know for sure, so this is something that you guys have to think about. I know in C and C++, you still can, even in C++, you can pass by reference, but you cannot pass an array by value. I'm pretty sure about that. Okay? So which is going to present a problem, because if you try to pass the array of available choices by reference, it will get smaller and smaller, right? So the first time you go in this direction, things are all good. The moment you return, it's not so good anymore. Because once you remove things from that array, they can never be added back. So you will have to make your own local copy of remaining choices before you pass it along to the next invocation. That's a big clue, because I can tell you this is something that is gonna bite, if you're not mindful about it. Okay. Any questions about this particular homework assignment? You have no limitation of how to structure the program. I don't think this is going to be a very long program, okay? Doesn't necessarily translate to an easy program, but it's not going to be very long, okay? A few things you might want to know in C++, because it's going to be a recursive subroutine. How do you debug a recursive subroutine? What are some of the tools that you can use to debug a recursive subroutine? Huh? The debugger, okay, the debugger is a good start, okay, so don't try to use cout or printf or anything like that to try to debug your program, because that usually will not be very productive. But even when you set up breakpoints in a subroutine, but since it's recursive, how do you know which level of invocation you're in? Backtrace, okay, BT in a debugger, okay? Not sure whether code blocks has BT built into the GUI, but you can always execute BT or backtrace in the command line portion of code blocks, okay? So BT is going to be really useful, because in case your program is doing infinite recursion, it's not ending. How do you know your program is not has an endless recursion? What would be the symptom of a program that has an endless recursion? Sorry?
Stack Overflow.
It will stop for sure, in really quick too, because it's going to be stack underflow actually, because the stack rolls down. So even though you're running out of space, you're actually going below where the point is supposed to be. So I can give you some pointers right here. A few things. How many people are going to write this program without code blocks? Okay, so I'm assuming you're using a command line tool to do this. So the first thing is make sure you turn off optimization. Because if you turn on optimization, it will throw the debugger into a loop. Okay, so make sure the optimization is turned off. Okay, so first of all, I'll give you a program. Okay, let me go to the temp folder, because I have no intention of saving this. Okay, I'll call this endless. It's just a regular C program, and this is the simplest endless recursive subroutine I can think of. If you can think of a better one, let me know. There might be some simpler ones, I don't know for sure, but I think this is one of the simplest ones. Okay. So we'll do a GCC, and dash wall may complain in this case, because GCC is actually pretty smart about these things. So we'll see whether it complains or not. And Liz, let's see. Ooh, it doesn't complain about it. Cool. Okay. So if I just execute endless, it gives me a segmentation fault, which most people think has to do with accessing memory where you're not supposed to, right? Well, I did actually, because I actually used up the entire stack and tried to access the memory location below where the allocated space is for the stack. Okay, so but how do you know your program has this problem instead of something else? First of all, you want to debug. When you want to debug a program, you want to turn on the debug symbolic table, and also, if I were you, I would also specify uppercase O as 0, which explicitly turn off all optimization. I'm not sure whether GCC by default has optimization all turned off. It doesn't hurt to tell it, no, do not do any optimization. Leave my program as it is, okay? Okay, so now I can debug this program using GDB. GDB can run as an independent tool. If you use code blocks, GDB is built into it, depending on which file you install in Windows. But in one of the distributions, it is included. So in GDB, you can run the program just the same, and it's going to give you the same problem, which is a segmentation fault. Yep.
So is this built into GCC? The debugger?
No, GCC, if you install GCC, it does not automatically install GDB. So if you're dealing with a Debian or a Ubuntu distribution, you will have to install both packages. So GCC and GDB are different packages. Okay, so in this case, well, this is a little bit more useful because even though it still gives me a segmentation fault, it tells me exactly where the segmentation fault is. It is in the main function. Well, that is not surprising because I only have the main function, right? But in the case of having multiple functions, that might be helpful. But how many times did I go through the recursion? I want to find out. BT will tell me. Maybe not in this case because the stack just ran out. I'm just trying to find out a way to kind of show you guys how do you know you ran out of that stack space, okay? So let's go ahead and put a breakpoint on line 3, which is the only line that I can put a breakpoint on. And I rerun the program from scratch, okay? Now this is just a trick that you can do. I think it's RSP in this case because we have a 64-bit architecture. Okay, so at the first line, the first chance you want to insert a breakpoint to look at what is the stack value or the stack pointer. And for most of you, it's going to be known as RSP. In Windows, I'm not really sure whether it will still use the same terminology. But you just look at this number. And then what I'm going to do is I will delete the breakpoint and let it continue execution until it crashes. And then I look at the RSP again, and you can see that they are just a little bit different because I already ran out of space. So I need to put a breakpoint on main itself, rerun the program from scratch, and try to see if I can, nope, can't do that. I have to insert a statement in between because otherwise I can't put a breakpoint on the first instruction. Let me see. Okay, something stupid like that, because it just gives me a place to put a breakpoint. So I want to recompile the program. That's okay. It's just a warning that X is set but not used. It's okay in this case. Okay, put a breakpoint on main, run the program, IRRSP, look at the stack pointer, and then delete the first breakpoint, continue execution until it crashes, print RSP again, or IRRSP. Now we are seeing a big difference. Do you just see how the stack pointer changed from FF E10. Okay, let me just highlight which portion I'm talking about. Look, the 7 is the most obvious one. Okay, this 7 here. Okay, look at these 6 digits. It just got changed from these 6 digits. That's an indication that I just ran out of stack space. Okay? And I'm not sure whether BT would work in this case. Yep, it doesn't work. I guess it has to do with, we're in main, so it doesn't really work. Let me see if I can get this to work. Because I want to show you how to use a BT or backtrace, because it is a very useful feature in a debugger. Okay, so let me like that. Okay, so we still have an endless recursion here. Okay, so we still have an endless recursion, and then we do a BT. There we go. So the number that you see all the way to the left-hand side, #0, #1, and so on, those are indicating which frame we are talking about. 0 is the last frame, the most recent frame, and then 1 is the previous one, 2 is the one previous to that, and so on. So when you're debugging a recursive subroutine, it really helps to know the breakpoint or where you stop is at which level of the recursion. Okay. Now with BT, it will also be useful to use another command which is called frame. So when you use frame, you use these numbers. So let's say you want to go back to frame number 5, you just say frame 5. Okay. Now when you switch back to frame 5, then when you say print and then the local variable name, it will be printing the value of that local variable in that particular frame, not the last frame. So that gives you a chance of tracking down exactly how you got to the point where you think a problem happened. Is that making any sense? Yeah?
Why does it stop changing after number 2?
After change, because there's a lot more. You mean the BT why it stopped?
Yeah.
Because I typed Q because otherwise it keeps going.
Oh.
Because it's an endless recursion and it's really fast.
No, I was talking about how number 1, it changes from number 1 to number 2, and then it just stops changing altogether. Because then it's just repeating.
Oh, okay, let me see. You mean this part here?
Yeah.
That is the address. This is the program counter, where, what is the last point of execution in that particular frame. So I'm suspecting that 6E is corresponding to the actual call instruction, and then 6.9 is corresponding to some other things that would use up stack space, but not the call itself. So basically, with all the other frames, the error happens when we were actually executing the call instruction, but with the very last frame, we were already out of stack space. So that little bit of extra thing that we have to do before we make a call that potentially uses up stack space, it basically generated that seg fault with that instruction. So that's why it's off a little bit. All right. So any other questions about this homework assignment? You got 1 week to work on this, and then your next homework assignment is going to be based on this, because this one generates the experiment space, and then the next one is going to be a filtering mechanism where you will be counting how many rows of the experiment space will fit a particular criteria. Okay, because that's how we figure out the probabilities. So all of these programs are helping you to understand, okay, when we talk about discrete probability, what are we talking about? This is corresponding to omega, which is the entire space of everything that is possible. And then out of that entire space, the next few programs will try to figure out, okay, but we're only interested in da-da-da-da-da, okay? So how many of these rows would fit that description? Those would be the additional programs that we'll be doing. Is that okay? All right, I'll see you guys on next Tuesday. Have a nice weekend. It's going to be a warm weekend. Yard work.